how model merging represents the next frontier in AI, as well as in transfer learning, and what potential you see in this technology for transforming various industries. So I guess that's a two-parter. So give us some insight into what model merging is. Explain it, because you could do a better job than I can. You're the expert on that. And then explain to us the potential you see in this model merging. And then I've got lots of follow-up questions related to that.
Absolutely. So model merging it's a family of techniques that let you take the pre-trained weights of neural networks and combine them into a single network that captures some of the strengths or abilities of all the networks that you threw, into that melting pot. And of course, there's a big variation in the sort of techniques, what performance characteristics they have, and what scenarios they excel in. But essentially, it's sort of a natural advancement of the philosophy of transfer learning. So, we discovered that if instead of training language models from scratch every time on however many trillion tokens and then throwing in our specific task, if we just do the foundation model training once and then fine tune many different versions of that on our various different tasks, then we get better performance, and it's infinitely cheaper than training everything from scratch every time. Model merging is very similar in that it's an even further, finer subdivision of the work involved. So whereas with typical language model training setups today, you'll take some foundation model like Llama 3, 8 billion parameter, the untrained base model, and then you'll curate some extensive data set that reflects what you want it to be capable of doing, which includes just general instruction following capabilities. You need a very diverse data set to get a robust instruction following capability in a text model. So you get all of that data, and curating all of that data is quite difficult. The open source community has some good ones, but it's still not to the level of what companies like Meta or OpenAI, for example, have curated. Then on top of that general stuff, you also need to curate a specific data set for the task that you actually care about. So say you're a finance company and you want a language model to summarize financial statements. You need to curate that data set. And then you train the model on top of that entire aggregate pile. And the end result is fantastic. But there's really no reason to be doing 90% of that work, because we have incredible, instruction following models available, open weight just on the internet. If you create just the data set for your specific tasks, then model merging is a tool that lets you take those pre-existing artifacts and incorporate their strengths essentially for free.
Yeah, so let me try to explain in my own words, and you can tell me where I get this wrong. When you have out there in the world, there's lots of different kinds of specialized models that are great at different tasks. And right now, if I was without model merging, if I was going to try to make use of that, I might have some kind of separate model that is predicting where to triage requests to. And then I'd have to grab, so let's say there's like 5 different tasks that I want my LLM to be able to perform really well at. And so I train probably myself this model for triaging natural language requests that come in. And I then, based on that, I get some probability that, okay, this is a great situation for model 2 out of 5. And then I separately call just that one model and send the original natural language request to that, allow it to follow through. That is going to require me to have a whole bunch of different models in production, which could be all very large, requiring a bunch of GPUs maybe to be in production running at great expense to me. With model merge, I can have one model running that is probably smaller than my 5 in aggregate. And so that means I can reduce my compute costs and probably also deliver results more rapidly in real time to my users.
Absolutely, yeah. So that's one very important use case of model merging, and it is good to highlight, as you did, the size of the models involved. So for most of these model merging techniques, you put in some number of models that are all the same size, and you get out a model that's that same size, just one model. So to give a concrete example there, so that wording was not great. Say that you've trained 7 or 8 models based on Llama 3, 8 billion parameters. And you put all of those into a merge, the model that you get out is still just 8 billion parameters. So versus, a classical unscheduled technique, for example, where you'd inference each of these, 7 models
Mhm.
and then combine the results at the end. You're just inferencing a single model.
Mhm, mhm.
It's the same size as each of these individual ones.
Yeah, and so let me make sure that I'm understanding this. So you could actually, so if I was starting with 5, like 7 billion parameter models, kind of like a common size that we see these days.
Mhm.
So let's say I have 5 different 7 billion parameter models. With model merge, when I merge them, I end up with one 7 billion parameter model.
Exactly, yes.
That is pretty wild.